All right, so I think this is recording. Let's take a look at these problems. It's matching. Which of these trig functions are not continuous? Well, sine and cosine are continuous, but the others um, are either they have a variable in the denominator. That the secant and cosecant are reciprocal relationships with sine and cosine. Tangent is sine over cosine. Cotangent is cosine over sine. So the ones that are not continuous are C, D, E, and F. They have vertical asymptotes. Um, which of these have a period of 2 pi? Well, 4 of the 6 of them have a period of 2 pi. The ones that don't are the tangent and the cotangent. They have a period of pi. So these other 4, A, B, D, and E, have a period of 2 pi. Ones that have a vertical asymptote here at 0 and at integer multiples of pi, well, the sine curve intersects the x-axis at the origin at 0. So since this graph has this shape and the point that I have of interest right now is here, so if sine is in the denominator, then it's going to have a vertical asymptote as the y-axis and any pi units apart. So the tangent is sine over cosine, so that's not. I'm looking for a sine in the denominator. This is 1 over cosine, so that's not it. Here, I have a sine in the denominator, so that's definitely going to be an answer. And I've got cosine of x over sine of x, and there's another sine in the denominator. So E and F definitely have a vertical asymptote at 0 and at any integer multiple of pi away from 0. All right. Sine and cosine have a range. Let's just go through and 2 of them have the range of, and there's a typo here. This should not be brackets. We should never have brackets around the infinity symbol. So that's definitely a typo. The range between the range of sine and cosine is between -1 and +1. The secant is from -infinity up to -1 in union with 1 to infinity. And that's the same for the cosecant. So the two that we're looking for, the two that have a range of all real numbers, are tangent and cotangent. So C and F. And make that correction on your paper as well. Goes through the point 0, 1. Well, definitely cosine does, because the general, remember sine goes through the origin, but the cosine, when x is 0, y is 1, we've got it as its starting point. So I'm interested in graphs that go through this point. Well, it's going to be cosine, and it's going to be the secant, because when we take the reciprocal of cosine, we've got this graph that goes up like this and like this. So you can see it goes through 0, 1 as well. That the secant of 0 is equal to 1 and the cosine of 0 is equal to 1. So B and D are these guys. All right, so undefined at pi over 2. Well, let's look at cosine again, because at pi over 2, cosine has an x-intercept. So anytime that cosine is in a denominator, you're going to have a 0 in the denominator at pi over 2. So tangent is sine over cosine. So it's going to have it's going to be undefined. It's going to have a vertical asymptote at pi over 2. And the secant, since it's 1 over cosine, it's going to. And the others are not. Cosine's not in the denominator. So C and D is that answer. All right, so let's see what we got next. We have these graphs. All right, so for the cotangent graph, I'm looking for, this is cosine over sine. I need to pause this for a second. All right, so I'm back. I was chewing a breath mint, and then I started being self-conscious that I might be chewing that in the microphone, and I wouldn't want to hear that, so I didn't want to do that to you. All right. Cotangent is cosine over sine, so it's going to be undefined when sine is 0. Sine is 0 at pi and integer multiples of pi. So here in the y-axis are going to be vertical asymptotes for the cotangent, and if this is pi over 2, the cotangent of pi over 2 is 0, because on the unit circle, if you're at pi over 2, you're up here at a point that's 0, 1, and cosine over sine, the x-coordinate divided by the y-coordinate is 0, and in the first quadrant, if you go here at pi over 4, you'll be at 1, so it's going up like this towards its vertical asymptote, and at 3 pi over 4, you'd be at negative 1. The cosine of, or cotangent of 3 pi over 4, you're in quadrant 2, that's negative. And x and y at 3 pi over 4, you've got negative radical 2 over 2, and positive radical 2 over 2 is the x and y coordinate, and x divided by y, x and y are the same in magnitude, which means they're going to cancel, and negative 1 divided by the positive, hey, that's negative 1. So I'm looking for this as my cycle, so I can see it's definitely not going to be these ones that are parabolic in shape. It's not going through the origin. It looks like that it's here at C, because here in E it's going through, yeah, it has to be, this first one has to be C. So for secant, it's the reciprocal of cosine, so we're going to look and see where we find the cosine curve. And so here is the cosine curve, and when you take the reciprocal of 0, you get a vertical asymptote. When you take the reciprocal of 1, you got 1. And when you take the reciprocal of negative 1, so this secant has the graph of D. The tangent will be similar to the cotangent in its shape, but for tangent, you it's sine over cosine. So it's going to have vertical asymptotes wherever cosine is 0. Cosine is 0 at pi over 2. So here at pi over 2, and here at negative pi over 2, we have a vertical asymptote. I know that it goes through the origin because the tangent of 0 is equal to the sine of 0 divided by the cosine of 0. The sine of 0 is 0, cosine of 0 is 1, and 0 divided by 1 is 0, so I'm going there. Now that at pi over 4, the tangent of pi over 4 is 1, and the tangent of negative pi over 4 is negative 1, so I'm looking for this as the primary period for my tangent graph, and it looks like I see it right here in choice B, and it's the only one that seems to be likely. Alright, so let's clear our graphs. A reflection across the x-axis for the cosecant. Well, let's look at a reflection for the sine. So let's find the sine of x, and actually the reflection of the sine of x. So sine would normally go up and then down, but since we have a reflection, we want to look for this. So here we go. If I if I draw this sine curve into here like this, you can see that it's going through the origin, and when you take the reciprocal 0, it's undefined. Reflecting across the x-axis doesn't change the x-intercepts for the sine curve, but it does change the max and min. See, normally at pi over 2, the sine curve is a max of 1, but now because this negative sign, it's at negative 1, and if you reflect negative 1, well, you get negative 1. So here, this guy has to be the graph of f. Now, tangent is an odd function, and we know which one is the graph of tangent. That's b. And although the negative sign in the front here is saying to reflect it across the y-axis, it would also be the same graph to reflect it across the x-axis, because the tangent of the opposite of x, so it doesn't matter how I reflect this graph of b. If I think of it in reflection in terms across the y-axis, this thing over to the right is now over here to the left, and what was to the left is now to the right. Or if I flip it across the x-axis, what was up is now down. So with an odd function, these two graphs are always the same. So let's look for something that's going through the origin, only coming at it from here, and it looks like it's down here at choice E, right? Yeah. Alright, so there's those answers. Hey, I think that's it. I'll talk to you later. Hope that helps.